I'm Stefan. In this tutorial, we're going to learn everything we need to have a very successful graph. For example, we have to know the domain, the real zeros, limits, asymptotes, derivative, if the function increasing or decreasing, and then we can maintain a very successful graph. First of all, let's do the domain. The domain, how we do the domain, we see where is the restriction, what numbers that makes this function undefined. The top is okay, could be any number, that's fine. Restriction that we have, this number here shouldn't be equal to 0 because we can't divide a number by 0. That's the reason. So we have to exclude where this function, this x squared minus 4 equal to 0. So let's do that. So x squared minus 4 shouldn't be equal to 0. Therefore, x squared shouldn't be equal to 4. So it's going to give us that x shouldn't be equal to 2, and x shouldn't be equal to minus 2. Therefore, D, the domain, is going to be equal to minus infinity minus 2 union minus 2 union 2 infinity. This is the domain of this function. What this tells us that this function is defined in all number except 2 and negative 2. Therefore, this x equal 2 and x equal minus 2, they will be a vertical asymptotes. So let's do it here, so we will have more information about this function. We'll have x equal 2 and x equal negative 2, they are asymptotes for this function. Second one, we are going to see where is the real zeros. So 2 real zeros. What does it mean real zeros? Where this function equal to 0, if x equal to 0, therefore it has to be this equal to 0. So we'll have f of x equal to 0 give us that 2x to the third equal to 0, give us that x equal to 0. So the real zeros of this function is x equal to 0. So we know that the function is going to pass by this point here, by the origin. Another information we know. So let's do some limit now. Limit x of x, when x goes to infinity, of f of x is only limit x to infinity of 2x to the third over x squared is going to be just infinity. What we did it here, the idea when we have a limit to infinity or minus infinity and we have something like this, we take the highest power from the bottom and from the top, from numerator and denominator, and then we see here if we cancel 2, we will end with 2x, and 2x is just infinity. And we do the same thing for minus infinity, and over x to minus infinity, same thing is just x to the third over x squared. Why? Because this 4 here doesn't count because it's a very tiny number compared to infinity. We will have same thing, we will end with limit of x to minus infinity of 2x. You see we can cancel x squared from here and x squared from here, so it's going to have here minus infinity. We have here infinity minus infinity, and now we're going to do the limits. Where is x, where is if the function is undefined, will be here in this point in 2, in the right and in the left, and in 2 in the right and the left, and negative 2 in the right and the left. We see where is the function is going. It's like this or like this, like this or like this. We have to find that. So we do the limit of x when x goes to negative 2. Minus means when you put the minus on the top means you are going to find the limit in this side here. When you put plus means in this side here, but on the left and the right of that number negative 2 and 2. So we're finding it on the left. So of f of x is going to have limit from x to negative 2 minus of x to the third over x squared minus 4. So we'll have here is 2 to the third, just 8, 16, but is minus 16 over, and this number here, we know that the absolute value in this side of negative 2 is bigger than 2, is bigger than 4, because if we take this number is bigger than negative 2, smaller than negative 2, but the absolute value is bigger. If we square it, means this number here is going to be positive. It's almost 0, but it's positive. It's tiny, but it's positive, so it will be almost 0 positive, and we will have minus infinity. This is the way on the right, to negative 2 plus of f of x. We will have just negative 16 as well over 0, but this side here, we know 0 is absolute value of negative of x close to here to negative 2. It will be less than 4. Therefore, this number here, it will be negative. Therefore, this 0 is going to be 0 negative, and we will have infinity. So let's do the same thing in the number 2, limit of x when x go to 2 minus of f of x. We will have is just 16. Same thing, is just, you see, it's the same thing because we don't repeat a lot, so we don't waste a lot of time. It's just 16 over 0, and we know 0 in this side. Same thing, absolute is if we take x square here, x wherever we take it, it will be less than 4 because x is less than 2. Therefore, this number here is going to be 0 negative, and we will have minus infinity. This is not 0 because we can't divide by 0. This means this is not 0. This means a number is really close to 0 but is negative. Same thing, limit of x goes to 2 plus is just of f of x is just 16 over 0 plus, and we will have infinity. Of here infinity, and we have here minus infinity. So what this tells us that we now know that that x, that if the graph of x in when x goes to infinity, f of x go to infinity will be something like this, going to infinity. And we know this when we have 2 on the right of 2 is infinity. We know it's something like this going up, just we have an idea. And we know here is going down. This is what the function what limits tell us, and we know here is going up. Let's have an idea. And we know is going, the graph is going from here, and here we know is going down as well, and here we know is going up as well. When x go to minus infinity, f of x go to minus infinity as well, is something like this. So we have an idea right now. So now what we're going to do, we're going to find the asymptotes. We already have 2 asymptotes. We have the verticals, and we see that we have an observation that we know when limit of f of x when x goes to infinity and minus infinity. If he give us infinity or minus infinity, is it possible that we have an oblique asymptote. What is mean oblique asymptote? An asymptote is something like this or like this. It's not vertical and not horizontal. So what we do to make sure we test our functions, our what we taught. So what we do, we are going to do limit of x, limit to infinity of f of x over x, and we see how much. So what we're going to get here is limit x to infinity of to x to the third over x to the third minus 4x. Just we multiply the bottom in x because we have x here, we multiply the bottom, and we will have here is just limit from x to infinity. Same thing, we select the big numbers here, and we will end with the x to the 2x to the third over x to the third, and we cancel this, is going to give us just 2. Let's write it here, just end of x to the third over x to the third, and we cancel this and give us 2. Same thing we do, and now when we have this 2, this is what does it mean? That we have an oblique. This means that we have an oblique line asymptote. It will be y is equal to x plus b. This 2 comes from here. So where we find this number when we do limit of f of x over x, it gives us the slope of the line. So we know this is 2 is the slope of the line, and we are going to look for b. And the way to find that b is we do limit of x infinity of f of x minus 2x. So we find the slope and multiply here on x because we have 2x plus b, and then we subtract, we take a limit of f of x minus this. This is what we did here, and what we're going to have is just limit from x to infinity of 2x to the third over x squared minus 4 minus, so we multiply this x squared minus 4 multiply into x, so we have same denominator. We're going to get just 2x to the third minus 8x plus 8x here. Okay, is correct, over x squared minus 4. Okay, so we see that this is going cancelled, and we will end with 8x over x squared, because infinity will be just 0. So we know that y equal 2x is an oblique asymptote. So we now know that we have this function here, and this y equal to x and y equal to x, it will be something like this. When x equal 1, y equal 2. So we know that the function has an oblique asymptote, something like this. And the same thing, if we do infinity, we'll get same thing, because it will be just 1. Now we're going to find the derivatives. So let's do that, delete all this. So we're going to find the derivative of this function. F prime of x is going to be just 2x to the third over x squared minus 4 prime, and is just 2x to the third prime times x squared minus 4 minus 2x to the third times x squared minus 4 prime over x squared minus 4 squared. When we have something like that, the derivative is very simple. We just would do derivative of this one, multiply in this one, minus this one, multiply and derivative of this one over this one squared. This is what we did here. This is the way we do the derivative when we have a rational function. So what we're going to get in this case is only this one here give us 6x squared times x squared minus 4 minus 2x to the third times 2x of over x squared minus 4 squared, and we will end here 6x to the fourth minus 24x squared minus minus 4, not 6, minus 4x to the fourth, all of this over x squared minus 4 squared, and we will have this with this, we will end 2x to the fourth minus 24x squared over x squared minus 4 squared, and we will have here just we can factor by 2x squared, and we will have here just x squared minus 12 over x squared minus 4 squared. So this is the derivative we will have. We see that this part here is positive and this part here is positive, so we have to worry just about this one to know the sign of this of the derivative, and the sign tell us when is derivative is 0 means that the function is constant, when derivative is positive means it's an increasing function, and when it's negative means it's decreasing function. So let's see where is this function is increasing and decreasing. So it's better we do a table like this, something like this, maybe a table close here. To have more how this function is acting, we put here 0 x, we have infinity, we have infinity here and minus infinity, we put all number we have, and we see this function here that derivative is equal to 0 at x equals 0, because this will be 0, and that x square is equal 12, so will be at x and x equal square root of 12 is just 2 square root of 3, and x equal minus 2 square root of 3. So we see this will be this equal 0 when is this equal 0 and this equal to 0. So let's block those numbers here, and we have 0, we have negative 2, and we have negative 2 square root of 3, and we have 2, and we have 2 square root of 3. This is everything we need, and we put here f of x, f prime of x, and we see the f prime of x is equal 0 here, and the function is equal 0 here, and this not defined, we do something like this, so like when excluding it, and same thing here, and the derivative is equal to 0 here. I'll leave it like that. So if we see the sign of the derivative, we now is just the sign of this one here. And what is the sign here? It will be positive, because when x is bigger than this one, absolute value will be is positive here, is negative here, negative here, negative, negative, and positive. You can always take a value to make sure. And therefore we know that the function is something like this, is increasing here and decreasing here, never touch this line here, doesn't touch this line here because it's undefined, and we now is increasing as well here, but here is fine, just cross 0, goes like this, at 0 is equal to 0, and we now is decreasing here as well, and we now is increasing here. This is the function. So what is tell us here, that here in this place the function has a local minima and here has a local maxima. And how we find those local minima and maxima is when those equal, when this here equal to 0, when here is equal to 0, we'll have inflection points, so the function is going to do something like this. But therefore when is positive, when is increasing and then decreasing, or increasing and then decreasing with something like this, we now is a local maxima and local minima. So how we find that? So we set this one equal to 0, f of f prime equal to 0 means this equal to 0 and this equal to 0. When this equal to 0 is fine because it keeps decreasing, will give us just inflection points, so will be where this equal to 0. So let's set that one equal to 0. So we'll have that and just do this, x squared minus 12 equal to 0. Therefore x is equal to square root of 2, 3, and x is equal to 2 minus 2 square root of 3. We already did it here just to understand what is going on. So we take this number here and we unblock it in the function in f of x, and so now therefore we know the values here. So let's do that. We have f of 2 square root of 3. What we'll have just 2 times 2 square root of 3 to the third over 2 square root of 3 to the second minus 4, and we will get here just 2. This one here just will give us times 2 times 8, here's give us 8 times 3 is 24 square root of 3 over here just 4 times 3 is 9, is 12 minus 4, and we will get here just 48 square root of 3 over 8, and we will get just 6 square root of 3. And if we see 12 square root of 3, how much? 12 square root of 3, 6 square root of 3 is just 10.4. So we know this is here, this point here is going to be 10.4, and here same thing, just will be negative, is minus 10.4. So we see that what we understand here, that the graph is going to come to here, to this point here, and go back. He will do something like this and go back, and here same thing, he comes something like this, 10.4, something like here, and he's going to do this and go back, and from here is going to do this, something like that. So let's take this graph and move it other side. So we have this graph here, so we do big one. So we said that we have 2 and -2 as vertical asymptotes. We have 2 and -2 here. And we said is going to pass by the origin by here, the function. And we have y equal to 2x. It will be a oblique asymptote. So it's be going from this point here, maybe something like this, more or less. This is going to be like a oblique asymptote. And then we have that we said the local maxima and local minima is going to be something like here, where is 10 is here, and here. So therefore the graph is going to be something like this. Change a different color. We say here is going to infinity to minus infinity, so it's going to be something like this, and come here and go back. Maybe something like this. And here we say that is going to plus from infinity here, and coming here, and does this, and at the same time goes here to minus infinity. So before we put the graph, we have an idea how more or less is going to look. And then here same thing is going from here, from infinity, coming, and arrives here and go back to infinity another time. So this is the graph how it's going to be. Everything you need to do it. Hopefully you like this video, and please share and subscribe, and thank you for watching. Bye. Thank you.